Hi, in this video we're going to learn about limiting reagents. Now, this might sound like a concept we have already learned, we just haven't called them limiting reagents yet. So let's go ahead and find out what exactly the word limiting means. Its general English meaning is already known. It means something that is going to limit whatever you're trying to do. And then obviously a reagent is a simple reactant. So a limiting reagent is a reactant that is going to limit whatever process you're trying to do. So the easiest way to explain this is in terms of an example. So let's go ahead and look at an example. So like I said, what does it really mean? And the easiest way to put it is whichever reactant runs out before the other one. Okay, so in this example I have said that you have 10 grams of both reactants. So what does that mean? It means that you have 10 grams of iron metal and 10 grams of oxygen gas, and they both react and make iron oxide. Now in this reaction you are going to run out of one of the two reactant. So my reactant number 1 is Fe and reactant number 2 is O2. Now whichever one runs out first would be the limiting reagent. Now how do you know which one runs out first? All you need to do is figure out which of these two chemicals. Remember that both of these are 10 grams, right? So one of these is going to give you the least amount of product. Whichever chemical gives you the least amount of product becomes your your limiting reagent. So let's go ahead and learn how to solve this problem. Now in order to solve this problem, you will see that I have made two charts. Why two? Well, because we have two reactants. And so say for example you have an example in which there are 4 reactants. You will have to set up 4 charts. And I know it sounds like a lot, but once you get the hang of it and you understand the pattern, this becomes super easy. So considering we have 2 reactants, I have 2 charts. So in the first chart I'm going to set up the chart for the first reactant, which is 10 grams worth of Fe. Now this is something that we have already done. You know that you will always start with whatever you have and then you will copy the unit down. So you put grams of Fe, which turns into moles of Fe. You copy that down on the bottom. Remember, we're doing this so that we can cancel the units, which turns into moles of oxygen. That is carried down on the bottom, and that turns into, actually, you know what, I made a terrible mistake, I'm sorry. And there you go, I fixed it. I apologize. So now we have our units set up. You started off with the given and you ended with what was needed. So now all you need to do is fill in the numbers. So you put 1 and then this would be grams of Fe. Alright, so I have put in all the numbers. So you get 1 mole of Fe is worth 55.845 grams of Fe. I got that number from the periodic table. For the mole to mole conversion, you have 2 and 4. I got these two numbers from the balanced equation. So 2 is the coefficient of Fe2O3, 4 is the coefficient of Fe. Then I got 159.69 as the molar mass of Fe2O3, and the number on the bottom is obviously 1. And so all we need to do now is do the math. So go ahead and hit pause, find the answer. And so after I do this math, the answer I got was 14.30 grams. Now what does that mean? It means that if I start with 10 grams worth of iron, then at the end I should get 14.30 grams worth of product. My product in this case is iron oxide. So this is my answer for the first reactant. And so what I need you to do is set up the other chart, and I'm gonna let you guys do this on your own. So go ahead and hit pause. What I need you to do is start off with 10 grams worth of O2, and I want you to end with grams of Fe2O3. Okay, so this is your product A, and this is your product B. So go ahead and hit pause, set up the chart, and when you hit play, you will see that I have set up the equation. Okay, so I hope you got the same answer. I got 33.27 grams worth of Fe2O3. Now, at this point, you can clearly see that I have two answers here, right? I've got 14.30 grams when I started with Fe, and I got 33.27 grams when I started off with oxygen. Realize that I have the same amount of both chemicals, right? I started off with 10 grams of iron, and I started off with 10 grams of oxygen gas. However, my answer for oxygen was much more compared to my answer for iron, which means that iron, Fe, gives me the least amount of product. Oxygen, on the other hand, gives me more product. What does this really mean? And you guys need to pay attention to what I'm about to say. If you don't understand what I just said, please go back, listen to it again, and listen to it again if you don't, because this is extremely important. In this example, we would say that Fe is our limiting reagent. And so what I'm going to do is I'm going to write that in red. Why red? Because this is going to run out first compared to oxygen. My iron metal is going to run out in a flask. Say I take 10 grams of iron and 10 grams of oxygen, and they react with each other. There will still be oxygen gas left because your iron will have reacted, all of it. There will be no iron left. You would still have some oxygen gas left. We know that because 10 grams of iron gives us 14.30 grams of Fe2O3, but 10 grams of oxygen gives me 33.27 grams of Fe2O3, which means that if I were to take 10 grams of each product, so I have 10 grams of Fe, and I have 10 grams of O2, right? When I combine these two, I am only going to get 14.30 grams of Fe2O3 plus excess O2. What does that mean, excess? It means it's extra. It was not used because your iron ran out first. That's what it means. So excess means extra, which means in this reactant, Fe was your limiting reagent. It is going to tell you how much product will be made. Now, let me state this a little differently. Say, for example, I had way too much iron. I had like a whole brick of iron, and I had 10 grams of oxygen gas. In that case, I have way too much iron and not enough oxygen gas, which means that oxygen would be my limiting reagent. So, which reactant is limiting is entirely dependent on how much of each you have. Okay, so sometimes you will see problems where it will say that you have two reactants and one of them is in excess. If a problem reads like that, you simply have to assume that the excess reactant is the one that you don't have to worry about, and then the other reactant becomes the limiting. So we're going to solve some more problems like this in class. We're also going to do a lab over this in class. So I expect you to have notes over this when you come to school on Tuesday. That way we can do some problems in class, and hopefully you guys will be better prepared for the test. It is also important to note that sometimes you will have problems. I take it back, not sometimes, pretty much always you will have problems that will not state directly that you have to find the limiting reagent. However, the minute you see you have two given quantities, remember that you have to find the limiting reagent. Okay, so it's not always expressly stated, but it is implied that you know that you need to find the limiting reagent. So with this, this concludes the video, and I hope you, if not completely understand this, at least have some good questions that you noted down on that left side margin, and when you see me in school, we will answer those questions and make sure that you ace this next test. Goodbye until then.